Hello dear students, welcome to this session. So we were studying the first unit of ICSE class 10 and that is force, work, power and energy. In today's session we will discuss about levers. In our previous session we discussed about the machine. Levers are also considered as machine, right? So let's start today's session with the levers. So what is lever? How can we define lever? Lever can be defined as it is a rigid bent or maybe straight bar which can turn around its axis. So lever is nothing but a straight or bent bar like this, and if we will fix it here, then it should turn around this axis. Means it should turn, it have the capability to turn around this axis. Then this bar will be considered as lever. Then this bar will be considered as lever. Suppose that this is a bar. If I will fix it here and it can turn around this fixed point or this axis, then this one will be considered as lever. Okay. Moving on next. Principle of a lever or mechanical advantage of a lever. So let's try to understand what is the principle of lever. So for that, first of all, we will define a lever. Suppose that this is a bar. Okay. So at this bar, there must be some fixed point known as fulcrum. And at one side, there must be some load. Suppose that here is some load. Okay, load. At another point, there must be some effort to make this bar in equilibrium state. The effort should be equal to load, right? Then only it will be in equilibrium state. So this is effort. Let's point A, point B, and this is fulcrum. This distance will be known as effort arm. Effort arm. Right. This distance between fulcrum to A, FA, is effort arm. And FB, this distance, DL, this distance, FB will be considered as load arm. Right. So this is a lever. Okay, so FB is load arm. Now, how we will get the maximum mechanical advantage? So, if we want that this rod should be in equilibrium state, if we want that this rod should be equilibrium state, then we have to apply the principle of moment of force, right? For equilibrium state, we have to apply the principle of moment of force. We have already assumed that rod or bar is weightless. Weightless. Let bar is weightless. Okay. Then according to principle of moment of force, clockwise momentum clockwise moment of force is equal to anti-clockwise moment of force. Anti-clockwise moment of force for equilibrium state. Let bar is weightless. According to principle of moment of force, clockwise moment of force is equal to anti-clockwise moment of force for equilibrium state. Right? If we want this bar should be in equilibrium state, then the clockwise moment should be equal to anti-clockwise moment of force. And this one will do clockwise moment of force, and this one will do anti-clockwise moment of force. As you can see here, if the load will be more, then it will go downward in clockwise direction. It will rotate like this. It will rotate like this. Here we have fixed, here there is a fulcrum, and if the load is more, it will do clockwise moment of force. And if we are applying more effort, then it will do anti-clockwise moment, right? So for equilibrium state, the clockwise moment of force should be equal to anti-clockwise moment of force. So what will be the clockwise moment of force? Clockwise moment of force will be equal to force multiplied by, which one is doing the clockwise moment of force? This load. So force into dl, right? And anti-clockwise moment of force, this effort is doing. So it will be equal to effort into dE, and here the force is load. So we can write load into dl is equal to effort into d. Have you got it? Moment of force is equal to force multiplied by perpendicular distance, right? So here the force is load in clockwise direction. When the bar will do the clockwise moment of force, the force is load and perpendicular distance is FB, and that FB is dl. So according to principle of moment of force, clockwise moment of force is equal to anti-clockwise moment of force. So what is clockwise moment of force? What will be clockwise moment of force? It will be equal to force multiplied by perpendicular distance, right? And which one is doing the clockwise moment of force? This load is doing the clockwise moment. It is doing the clockwise moment, right? So here the force will be load and the perpendicular distance is FB, which is equal to dl. So L dl. For anti-clockwise moment of force, the effort is applying the anti-clockwise moment of force. This is the direction of effort. So it is doing the anti-clockwise moment of force. What will be anti-clockwise moment of force? Force, which is effort multiplied by perpendicular distance, which is FA or AF, and that is DE. That is DE. So we can write down here clockwise moment of force L dl is equal to E multiplied by dE. So L upon E is equal to dE upon dl, or we can say L upon E is equal to mechanical advantage. Load upon effort is equal to mechanical advantage. So we can write mechanical advantage is equal to dE upon dl. dE upon dl. So here, from here, what are the conclusions? More will be the effort term, more will be the mechanical advantage. Mechanical advantage is directly proportional to effort term. So how long you will keep the effort arm? You will get the maximum mechanical advantage. If the load arm is greater than effort arm, then the mechanical advantage will be lesser. If the both arms are equal to each other, load arm and effort arm are equal to each other, then the mechanical advantage will be 1. So if the both arm are equal to each other, mechanical advantage will be 1. If the effort arm is longer than load arm, then mechanical advantage will be greater than 1. And if the effort arm is shorter than load arm, then the mechanical advantage will be less than 1. So these are the 3 cases. Let it write down. The first one, if DE is greater than DL, okay, then mechanical advantage is greater than 1. Second, hence to get the maximum mechanical advantage, we should keep the effort arm longer, okay. If DE is less than DL, then mechanical advantage will be less than 1. And the third one, if DE is equal to DL, in that case mechanical advantage will be equal to 1, right? So these are the 3 cases we will discuss when we will discuss about the types of levers, class 1, class 2, class 3, right? So let's move on next slide. So kinds of levers. So first of all, we are going to discuss about class 1 levers. Let's see what are the class 1 levers. Suppose that this is a bar and this is the fixed point known as fulcrum. Here we are keeping some load, right? Or we can show it like this. Here we are keeping some load and here we are applying some effort. This distance between fulcrum to load is known as load arm, and this distance between effort to fulcrum is known as effort arm. So in class 1 lever, the fulcrum is in between effort and load. In class 1st lever, fulcrum is in between load and effort, right? This is the condition for class 1 lever. Fulcrum will be between load and effort, okay? So here are some of the examples. Pliers, seesaw, crowbar, these are the examples of class 1 lever. Let's see here. This is the fixed point known as fulcrum. Here we are applying effort, here we are applying effort, and here we are keeping any object or cloth, means this is our load. So the fulcrum is between load and effort. In this case, here we are applying effort, right? This is the point where we catch the hammer. So this point will be effort point, or we will apply effort at this point, right? Here will be some load. Suppose that we have to knot this nail. Then this is the load point, okay? And this is the fixed point, fulcrum. Here it will be fixed, so fulcrum. Again, fulcrum is between load and effort. Okay, again the fulcrum is between load and effort. Similarly, for the crowbar, let's draw plier. Have you seen the plier? Something like this. Fixed at this point, and these are the handles. This is a plier. We keep some wire here. Okay, suppose that this is wire. So this is the load. This is fixed point, fulcrum, and here we apply effort. Here we apply effort. So this is another example. Seesaw, this is seesaw. Have you seen the child to play in the ground, when they go to play in the ground or in park, there are seesaw. One child sits here, another sits here. So this is another example of first class lever, because fulcrum is in between. One side is load, another side is effort, right? So this is another example of class 1 lever. In class 1 lever, there are all three possibilities. If the fulcrum is just in between load and effort, means load is equal to effort, means dE is equal to dL. In this case, suppose in this case, if dE is equal to dL, then mechanical advantage will be 1, right? Think about another case. This is effort, this is load, and fulcrum is somewhere here. This is also class 1 lever, but here what you are seeing, that effort arm is greater than load arm, right? Here effort arm is greater than load arm, so we will get the mechanical advantage greater than 1. In this case, the mechanical advantage will be greater than 1. And the third case, this is effort, this is load, fulcrum is somewhere here. So effort arm is much lesser than load arm. In this case, mechanical advantage will be less than 1. So in class 1 lever, there are all three possibilities, that mechanical advantage can be equal to 1, it can be greater than 1, as well as it can be less than 1. So this was the class 1 lever. We just saw the examples of class 1 lever. Now moving to the class 2 lever. So let's see for the class 2 lever. In this class lever, fulcrum at one side and effort at another side, right? This is effort, this is fulcrum, and somewhere there will be load. In between there will be load. So load will be between fulcrum and effort. In these class of lever, the load will be between fulcrum and effort, right? Such type of levers will be known as class 2 levers. Here is one of the example. This is the load, this is load, this is the fixed point fulcrum, and this is the point where we are applying effort. So this is effort point. So fulcrum, then load, then effort. Fulcrum, load, effort, means load is between fulcrum and effort. So this is class 2 lever. Nutcracker. Have you seen the nutcracker? In nutcracker, something, let's see. Unable to draw very good, but yes. You will understand. Here we keep the nut which we have to break. Here we keep the nut which we have to break. So this is load, right? This is load, and here we are applying the force. Here we are applying the force. So this is effort, and this point is known as this point is known as fulcrum. Okay, F. Here this is fixed.,. Okay, we are keeping some load in between. So this is effort, and here we are applying the force. Here we are applying the force. So this is effort, and this point is known as fulcrum. Okay, F. Here this is fixed. Okay, we are keeping some load in between. So this is effort, and here we are applying the force. Okay, and here we are applying force. So this is very bad example by the art. That is why we took already driven drawn figures here. So better to understand with this in place of this. That was horrible one. So here we took one of the example. Another example is this, the bottle opener. Okay. So if the bottle was there, suppose that this is the bottle which we have to open. Okay. Milk is there inside, not cold drink. Okay. So we have to open here. We are applying effort from here. Okay. Load is here. This is the load, and fixed is here, F. When we will tight it, then it is fixed here, and we are applying with effort from this side, and load is here. So this is another example of class 2 lever. Suppose that this is a stone and we have to move it, then we will use a bar, straight bar, like this. So where is we are applying effort? Here we are applying effort, right? And this is the fixed stone, means this is the fulcrum, and load is this one. This is the load which we have to lift. This we have to lift. So load is this one. Here it is fixed. This point will be fixed, right? This point will be fixed. Load is this, and here we are applying force. So this is what another example of class 2 lever, right? So I think that you must be aware with the class 2 lever with these two examples only. If you want to understand with this too, you can. Okay, moving on, the third type lever or class 3 lever. So this is class 3 lever. The example is of sugar tongue. Here in this type of lever, there is fulcrum, effort and load. Right? Effort is between fulcrum and load. Right. Effort is between fulcrum and load. As you can see, this is the fixed point, means fulcrum. This is the point where we are applying effort, and this is load. So effort is between fulcrum and load, right? Knife is another example. Knife, suppose that this is knife we are holding in our hand. So this will be the fixed point where I am holding the knife. This is the fixed point, right? This is the fixed point. Applying effort here, and here there is load, right? Here there is load. So load, effort and fulcrum. Effort is between fulcrum and load. So this is another example of class 3 lever, and it is knife. Example of knife. Okay, this is your hand, not mine. This is your hand where you have fixed the knife. Okay, so this was the third kind lever, class 3 lever. The main thing is that what will be the position of effort, load and fulcrum. So here again the effort will be between fulcrum and load. As I shown here, this is the point where this is fixed, so this will be the fulcrum. We are applying effort from this side, means effort is in between, and load is here. This is the sugar tongue, load is here. Okay. Now there are some of the example of each class of lever found in our body. So the first example is our head. When we nod our head, right? So this is the point where the load exists. This is the point where load exists. And this is the point where it is fixed. And I am applying the force from back side. Let me draw another example. Is it looking like a mango? Okay, so this is point where the load exists. Okay, this is the point where load exists. And this is the point which is fixed. And from here we are applying effort. So which condition is this? Fulcrum is between load and effort. When we are nodding our head, then effort is applied from here at this point. The fulcrum or fixed point is this in between, and this is the load. So this, which class lever is this? This is class 1 lever. Class 1 lever. See another example. Suppose I am keeping some weight on my hand. This is my hand and I am keeping this load on my hand. So of course this is the load point. This is the load point. It is fixed here. It is fixed here, and when I am trying to pull it or uplift it, then I am applying force from here. So this is the effort point. This is the effort point. This is fulcrum and this is load. Let's see. Load is here. Okay. This is the point from where we are applying effort, and this is fixed point. This is the point which is fixed, fulcrum. So which class lever is this? Load, effort, fulcrum. This is class 3 lever. Class 3. Okay. Now the remaining one. Another example. Let's see. Suppose that I am standing on my toe like this. On my toe like this. Okay. So this is the point from where load exists. Okay. Here the load exists. This is the fixed point. This is fixed point, and I am applying effort at this point. E, effort. So in this case, the load is between fulcrum and effort. Which class lever is this? This is class 2 lever. Class 2 lever. Are you getting? I am standing on my toe like this. Then this point is fixed. This is the point where load is applicable, and this is the point from where we are applying effort to stand in this position. So this is the example of class 2 lever. So these were some of the examples through which we can understand the levers in our body, in a human body. So with this, I would like to wind up this session over here. There is a beautiful quote for you. Hate will only eat the truth, then spit out a lie. It is very difficult to carry on something for a long duration. If you will carry on this very light-weighted marker on your hand, then initially you will not have any pain. But if you will keep carrying on this for hours, then it will be very difficult for you to keep it, right? So what does it means? It means if you are carrying hate with yourself, then after some time it will be very difficult for you to carry on the hate. In that case, you will start telling lies. You will start telling lies. You will say to your whoever is inspecting you, you will tell that yes, I am keeping it since hours, though you have taken rest in between, but you will say that yes, I am continuously keeping it on my hand, right? So there will be space for lie, and that what does it means? So when you will keep on hate with yourself, then it will only eat the truth and you will speak lie. Okay, hope that you got the meaning of this quote. So with this quote, would like to wind up the session over here. We'll meet in the next session. Till then, take care of yourself. Have a very good time.